That's not just the sound of that first sip of Morning Joe. It's the sound of someone shopping for a car on Carvana from the comfort of home.
That's a good blend.
It's time to take it easy, like answering some easy questions to get pre-qualified for a car in minutes.
Talk about starting the morning right.
Just like customizing your terms so your car fits your budget. Visit Carvana.com or download the app to experience car shopping the way it should be. Convenient, comfortable. The comfort of your favorite seat is now your comfy car selling command center, thanks to Carvana.
It doesn't get any better than this.
Your favorite seat's the best spot in the house. Make it even better by entering your license plate or VIN and getting a real offer in minutes.
There really is no place like home.
And speaking of home, Carvana will pick up your car from yours after you finalize your offer. Visit Carvana.com or download the app and sell your car from your comfy place.
Welcome to Alien Theorists Theorizing. We got a special episode today. We have Avi Loeb on. I'm Braden.
I'm Zell.
I'm Dan.
And this, of course, is Avi Loeb.
That is Avi Loeb over there on the other end.
Thanks for having me.
Thanks for coming on the show. And for those of you who don't know, Avi Loeb is the founding director of Harvard University's Black Hole Initiative, director of the Institute for Theory and Computation at the Harvard-Smithsonian Center for Astrophysics, the former chair of the astronomy department at Harvard University. He chairs the advisory board for the Breakthrough Starshot Project and is a former member of the President's Council of Advisors on Science and Technology and a former chair of the Board on Physics and Astronomy of the National Academies. Safe to say, the smartest man we've interviewed on the show thus far.
Yeah, bar down, 100%.
He's going to be speaking at Contact in the Desert at the end of June here. So, Avi, just the first question I want to ask you is, what was the catalyst that got you started into like astrophysics, astronomy, just space in general? Was there like a central event as a child, or what got you going?
Well, it was just circumstances. I grew up on a farm. I used to collect eggs every afternoon, and I was mostly interested as a kid in philosophy, in the most fundamental questions. And I used to read philosophy books while driving a tractor to the hills of the village every weekend. And but then I was born in Israel and I had to serve in the military. That's obligatory at age 18. And I had two options, either to pursue physics and get recruited to a program that allowed me to get a PhD in physics, or to run in the fields with a gun. And I preferred the first because it's closer to philosophy. And then I proposed a project that was funded, the first international project to be funded by the Star Wars initiative of President Reagan back in the mid-1980s. And that became a whole department. And I was one of the leaders of that project, and visited Washington, D.C. In one of the visits, I went to Princeton, New Jersey, and visited the Institute for Advanced Study, where Albert Einstein used to be a faculty decades earlier. And they offered me a 5-year fellowship under the condition that I'll switch to astrophysics. And I couldn't turn this down. It's just like this offer, in The Godfather that you cannot.
He made you an offer you couldn't refuse.
Yeah.
Exactly. And then after that, there was another one that came from Harvard University that I couldn't refuse for a faculty position. And at the end, it was just like an arranged marriage. But I felt that I'm actually married to my true love, because in astronomy, we can address philosophical questions using the scientific method. So I'm quite happy that I ended up along this path, but it was not my choice, you see. But it ended up bringing me to exploration of space. And, in 2016, we announced the first project to visit the nearest stars. It's called the Starshot.
Right.
And that's the most ambitious space project there is.
Starshot is a project to send like a probe to another system, or what exactly would you be sending?
Right. So in May 2015, an entrepreneur from Silicon Valley came out of a black limousine in front of the Center for Astrophysics at Harvard, and entered my office and sat on the sofa in front of me and asked me, his name is Yuri Milner. He asked me whether I'm willing to lead a project to visit the nearest star within his lifetime. And that meant getting there within, let's say, 20 years or so. And I knew that the nearest star is about 4 light years away. So it takes light 4 years to get there. So the spacecraft had to move roughly at a fifth of the speed of light in order to get there in 2 decades. And that's 1,000 times faster than all the chemical rockets we've used in the past. So a factor of 1,000 is just like the difference between all the spacecrafts that we launched, starting with Sputnik, compared to the car that Henry Ford invented, so that it's a huge increase in speed. And I told him I need to think about it. And eventually, with my group, we recommended one technology that can accomplish that, and that's light sails. And basically, the idea is to have a very thin film, very thin layer of material that is being pushed by a very powerful laser. If it weighs less than a gram and the laser has 100 gigawatt roughly in power, then within a few minutes it can be pushed by reflecting the light. It can be pushed to a fifth of the speed of light. And so that's the concept. And we are currently working on the technology to do that.
And so Breakthrough Starshot, that's the one that was founded in 2016. If I remember correctly, Mark Zuckerberg's involved and Stephen Hawking at the time was as well.
It is. We announced it in New York City, and Stephen Hawking came all the way from England for the announcement, the public announcement. He also, during the same 3 weeks that he visited us, he also participated in the inauguration of a new center that we have at Harvard called the Black Hole Initiative that I'm the founding director of. And that center is focusing on the study of black holes. And I don't know if you remember, but about a couple of years ago, there was a photograph of an image of a black hole.
We remember it.
It was really cool.
we've talked about that. Yeah, it made amazing.
And the place where it was derived, this image was in the conference room of the Black Hole Initiative. So we are very proud of that. And so, and Stephen Hawking came to my home during that visit. It was an interesting time. Both projects were announced around the same time.
Wow, that is really cool. So the closest star being Alpha Centauri, is that correct?
Yes. Well, it's a 3-star system. It has Alpha Centauri A and B, which are very close to each other. They're very similar to the sun, each of them. But then you have Proxima Centauri, the third, which is called also Alpha Centauri C. That's about 12% the mass of the sun. So it's a dwarf star. But we know that there is a planet close to it, with roughly the same surface temperature as the Earth. It's about 20 times closer to this relatively faint star. And it's so close to the star that one side of it faces the star at all times. So it has a permanent day side and night side. My daughters say that if we ever go there, they want a house on the strip that separates those two, because see the sunset. Just think about it, sitting in your porch and seeing the sunset forever. The sun never sets on that strip.
Yeah.
Right.
And you have your bedrooms on the backside, so you always it's always nighttime.
Yeah.
Easy to go to bed. And you got your little breakfast nook at the front. Yeah, it's perfect. I expect a lot of the population would be right on that equator.
By the way, I should warn you that this star emits mostly infrared light, not visible light.
Oh, okay. So
if there are any creatures on that planet, they must have infrared eyes. And I asked students in my class whether they know of any animal, any creature on Earth that has infrared eyes. One of them found an image of a shrimp, and the eyes look like 2 ping pong balls connected with cords. head of the shrimp.
It's probably, I think it's, what is it? Like it's the mantis shrimp. I think one of them, mantis shrimp, can see at least that's one type of shrimp. I know it can see in multiple spectrums of light, or at least that's what they understand from the structure of the eye.
All I'm hearing is that when we move here, we can still have surf and turf because I like shrimp. So,
or they're going to be giant shrimp people. So,
well, it may explain why they don't come to visit us, because interstellar tourist agencies will never advertise our vacation sites for them, because they are always illuminated by visible light, and that hurts their eyes. And green grass, they are used to dark red grass.
Now, Avi, the main reason we wanted you to bring on the show is you just released a book recently, Extraterrestrial, The First Sign of Intelligent Life Beyond Earth. And in that book, heavily you talk about the first interstellar visitor, Oumuamua, which was back in 2017, which we talked about. We have a segment on our show called Space News, and we were like, this is like, it was really cool at the time. And then it kind of faded away out of the mainstream, out of the news. And then you released this book. So for people who don't know or don't remember, what was this object Oumuamua, and why do you find it so interesting?
Oumuamua was the first object that came from outside the solar system that was spotted near Earth with telescopes. And it's sort of like finding an object from the street in your backyard. You can learn about the street without needing to visit it. And at first, astronomers thought, oh, it must be just like the rocks we have seen before from the solar system. Except it didn't look like any of them. It didn't have any cometary tail. There was no gas or dust surrounding it. And therefore, it couldn't have been a comet. It was definitely not a comet of the type that we have seen many times before. And also, as it was tumbling every 8 hours, the amount of sunlight that it reflected changed by a factor of 10. So that meant that it had a very extreme shape, most likely pancake-like, so a flat shape. Again, very non-typical. And moreover, this object exhibited an excess push away from the sun, and there was a force acting on it that declined inversely with distance squared from the sun. So the only way I could have explained that was to say that it's the reflection of sunlight that is pushing it. And for that to be effective, the object had to be very thin, sort of like a light sail.
Light sail, yeah.
Before. And, nature doesn't make light sails. And so I suggested that it may have been manufactured by another civilization. And there was another object found in September 2020, just about 7-8 months ago. And that object was given the name 2020 SO. It also exhibited an excess push from the sun by reflecting sunlight without a cometary tail. It turns out that the astronomers that discovered it with the same telescope in Hawaii, and by the way, that's why the name Oumuamua was given, because it means, Hawaiian language, it means a scout or a messenger from far away. At any event, this second object, 2020 SO, was identified as a rocket booster from a lunar lander mission in 1966. And we know that it had thin walls. It was very thin, and that's why it exhibited this push from the sun by reflecting sunlight. We know that it was artificial because we produced it. The question is, who produced Oumuamua?
Right. So Oumuamua enters our solar system. You predict it to, have an orbit or whatever around the sun, and then instead of like a normal comet, it might accelerate due to the gas pushed off of it from the evaporation, right? And this seemed, in your book, you say it had like a smooth acceleration, like it seemed like it was pushed along by some force.
Yeah, there were a couple of things that made it different from the regular push of a comet. Well, first of all, we didn't see a cometary tail. That's point number one. But usually on comets, the evaporation takes place in some hotspots that produce jets. And that introduces some jitter, some variation in the push as the object is tumbling. And different spots are being exposed to the sunlight. So we haven't seen any such jitter. There is usually a change in the spin of the object as different jets operate, and we haven't seen that kind of a change in the spin. And the other thing is that at a certain distance from the sun, water cannot evaporate anymore. So you stop having this cometary activity at some distance. And Oumuamua reached that distance, but the force continued to decline smoothly without an abrupt change, as you find in comets. So to me, that all of that was consistent with a push as a result of reflecting sunlight. And there was a lot of pushback from the scientific community to the idea that it's artificial. People ridiculed it and didn't want to discuss this possibility whatsoever. But all the suggestions that were made for a natural origin of this object invoked something that we've never seen before. For example, a cloud of dust particles that are very loosely bound, like a dust bunny that you find at home, 100 times less dense than air. The problem with that is when it gets close to the sun and gets heated by hundreds of degrees, it will not maintain its integrity. So that it will not hold together. There was another suggestion that it may be an iceberg made of hydrogen, so that when it evaporates, you don't see the cometary tail because hydrogen is transparent. And we've never seen a hydrogen iceberg,
right.
But if it existed, it wouldn't survive the journey because we showed in a scientific paper that it would evaporate very quickly. And then there was the suggestion that maybe it's a nitrogen iceberg, the size of a football field, chipped off the surface of another planet like Pluto that has nitrogen on the surface. The problem with that is the mass budget. You basically need 100 times more mass than you have in stars altogether to make enough nitrogen icebergs so that we will see one of them with SARS telescope in Hawaii. And so that doesn't work out either. And then there was a suggestion, maybe it's a fragment, a piece of a bigger object that was disrupted by passing close to a star. And the problem with that is usually you get elongated pieces, not flat pieces. And moreover, the chance of passing close to a star is very small. So these were the proposals made by scientists that tried to find a natural origin, and all of them contemplated something that we've never seen before. And so I made the simple point that if it's something we've never seen before, it may very well be a plastic bottle that we found on the beach. Most of the time we find rocks. Every now and then we find a plastic bottle that tells us there is a civilization out there.
Right.
And by the way, one more important point. It's very easy to tell the difference between the two, between a rock and a plastic bottle, if you have a close-up photograph. So if we get another object, as weird as Oumuamua was, to be identified by a survey telescope in the coming years, and we get the alert a year in advance, we can send a spacecraft equipped with a camera that will intercept its trajectory and take a close-up photograph, the way that the OSIRIS-REx, which was a mission to the asteroid Bennu, did. And they say a picture is worth 1,000 words. In my case, a picture is worth 66,000 words, the number of my book. I wouldn't write the book if you had a photograph.
No kidding. Dan, you had a question?
Just like a point of clarification that I wanted to ask you about was, you mentioned that Oumuamua was the first interstellar object to come close to our sun. Now, how often is that it's not the first interstellar object to come through our solar system, or does that point still stand?
No, it's not. Right now in the solar system, there should be a quadrillion of them, 10 to the power 15 of such objects, because it takes more than 10,000 years to cross the entire solar system, the Oort cloud,
right?
The speed that Oumuamua was moving. So right now, there are plenty of those objects. It's just the first one that we noticed because, Pan-STARRS did not exist. This survey telescope did not exist many years ago. This telescope was designed to find near-Earth objects. And, Congress about 15 years ago issued a task to NASA to find 90% of all the objects bigger than the size of a football field, 140 meters or so. That's roughly 1% of the size of the rock that killed the dinosaurs. That rock was the size of Manhattan Island, much bigger by at least 100 times. So we want to know of all the rocks that have a chance of hitting Earth so that we can we could deflect them and avoid a catastrophe. We are smarter than the dinosaurs were. They are not around anymore, but we want to survive such a hit. So that's why Pan-STARRS was designed. And in less than 3 years, there would be a much better telescope surveying the sky called the Vera Rubin Observatory, and it should find about 60% of all these objects. And so that was the goal. And then in the process of surveying the sky, completely by surprise, it found this object that moved much too fast to be bound to the sun. It was clearly from outside the solar system. It was moving too fast to be trapped by the sun. And so that was a surprise, because a decade earlier, I actually wrote the first paper that forecasted how many rocks should we see from other stars. And if you just make the analogy with the solar system, you wouldn't have expected Pan-STARRS to find any. So the actual detection of this object by itself was a surprise.
Right. Astounding. It's
amazing.
I definitely wanted to have you, someone who's knows what he's talking about, to make the point that it's absolutely incredible that we found it. Like, it's something monumental.
When we first heard the news, we were like, this is amazing. And then it died so fast. Like, does no one else think this? And then the opportunity to interview you came up, and like, oh yeah, this is going to be great. I wanted to go back to, because the shape of it. So in your book, you say it's like maybe 10 to 15 times longer than what it was wide. Was there what's the best guess of estimate of size?
Yeah, so the Spitzer Space Telescope tried to detect any heat emitted from this object. We know how hot it got because we know the trajectory, how close it came to the sun, and the temperature that you get to depends just on the distance from the sun. So from the fact that the Spitzer Space Telescope didn't detect any heat or infrared light coming from this object, one can put a limit on how big it was. We know the temperature, but if it was very small, then you wouldn't detect any heat because you get very little light coming from it. And so the limit was about 200 meters. That's the upper limit. It couldn't have been bigger than that.
Right.
It couldn't have been smaller than 20 meters, which is 10 times smaller than that. It couldn't be smaller than that because we saw a certain amount of sunlight reflected. So even if it was a perfect mirror, it should have been at least 20 meters. So somewhere between 20 meters and 200 meters, the size of a football field or 10 times smaller, that's the characteristic range that we can assign to this object. We don't know what is its reflectance, which fraction of the sunlight it reflected. So if you wanted to pick a guess, I would say about 100 meters in size. But then because the amount of light changed by a factor of 10 as it was tumbling every 8 hours, that meant that projected on the sky, it was at least 10 times longer than it is wide. But the shape of it was most likely pancake shape based on the analysis of the amount of light that it reflected. And the best way to think of it is just like a piece of paper tumbling in the wind. Intrinsically it's flat, but as it's tumbling in the wind, when you look at it, it looks elongated in projection. So there was this cartoon that was displayed in many places of a cigar-shaped object, but that's just in projection. If you look at a piece of paper in projection, it looks like a cigar, but intrinsically, it's like a pancake.
Right, or I've heard it mentioned before, possibly saucer-shaped.
That's not just the sound of that first sip of Morning Joe. It's the sound of someone shopping for a car on Carvana from the comfort of home.
That's a good blend.
It's time to take it easy, like answering some easy questions to get pre-qualified for a car in minutes.
Talk about starting the morning right.
Just like customizing your terms so your car fits your budget. Visit Carvana.com or download the app to experience car shopping the way it should be. Convenient, comfortable. Ah.
Man, that sunset is gorgeous.
Grill, patio, sunset. Hard to get better than that. Unless you're browsing Carvana's inventory while you soak it all in.
Oh, burger time.
So sit back, get comfortable. Carvana's got thousands of cars under $20,000 just waiting for you.
I could stay here forever.
Carvana, where car buying meets comfort meets convenience. Download the app or visit Carvana.com today.
Well, a flat object.
Flat object.
Yeah, you can make whatever you want out of it. But certainly not something we have seen before. And, this is the first time that we use scientific instruments, telescopes, and see something that looks unusual. And so I thought, just behaving like a kid, like someone that wants to understand the world, and I don't care how many likes I get on Twitter or how popular I am. I just put it on the table that we should, this is very intriguing and we should get more data. We should take a photograph of the next weird object. But to my surprise, there was a huge amount of pushback from other scientists. They didn't want to discuss this possibility. There was a talk, a lecture at Harvard about this object. And when I left the room with a colleague of mine, he said, this object is so weird, I wish it never existed. So actually bothered people that are these anomalies. They would have been happier if the anomalies did not exist. To me, that's surprising because I'm actually thrilled whenever there is something new. It's an opportunity to learn something new about nature. So we should be really glad if we see something that doesn't quite behave the way we expected.
Yeah, 100%. Like, I don't know why.
Yeah, I think that was the main point or the main takeaway I took from a lot of discussion about this was that you simply in your paper that you published in the academic journal, you mainly just entertain the theory. You just want people to entertain the theory that this object could perhaps be either a sign or an artifact of another intelligent civilization out there. And you simply you state it as that. It's like working off the data that we do have, which I guess relatively isn't that much. Like it's like, when you look at it.
Yeah. And the way I thought of this is just like a wake up call. We've been looking for radio signals from the sky, from other civilizations. We haven't heard anything. But that's just like trying to have a phone conversation. You need the counterpart to be alive. And it's possible that, there is no other civilization exactly at this time that is exactly at our technological maturity. So either there are most cultures that had this technology of radio communication, either they're dead or maybe they developed other technologies much more advanced than radio communication, and they just do not communicate by radio waves. But the point is, it's not the best approach to look for them because there may be a very narrow window of opportunity for another civilization to be exactly at the same technological development as we are. A much better approach is to search for relics that they left behind. On Earth, we are talking about archaeology, making archaeological digs and looking for relics that were left behind by cultures that existed in the past and are not around anymore. They died. And we can do the same thing in space. Most of the stars formed billions of years before the sun. So if they had civilizations like ours that sent equipment into space, like we sent Voyager 1, Voyager 2, New Horizons, there should be a lot of equipment out there in space accumulating over the billions of years. Most of it will be trash, will not be functional because a lot of time elapsed since this equipment was sent. But we can find it. Just like Oumuamua, we will see something unusual in the sky and we could take a photograph of it. And if it looks really artificial, then we can land on it. And maybe we can read off the label that says made on planet X. And maybe we can import the technology to Earth. That can be worth a lot of money.
So you're talking about investing more in space archaeology rather than because you say, like, I've heard you in interviews before say, people spend so much time on multiverse theory, string theory, all these interdimensional theories when And that's all. I mean, that's interesting stuff. But at the same time, chances of proof are much slimmer than finding an object tumbling around space.
That's right. And I simply cannot understand the resistance to discussing technological relics, searching for them and investing the funds to find them. You see, for example, the National Science Foundation invested $1.1 billion in looking for gravitational waves. And the astronomy community invested hundreds of millions of dollars searching for the dark matter, what makes most of the matter in the universe. We don't know what it is. And we haven't found it. But in all cases, we invest huge sums of money to find evidence for something new. And we should expect the same. Here, if we don't put the effort, if we don't put $1 billion forward in the search for technological relics, we might not find it. It may be a self-fulfilling prophecy to say, oh, it's always rocks. Let's not even imagine that possibility. And when people argue you need extraordinary evidence, my point is they don't allow for that evidence if they ridicule it to start with, and if they don't fund it at the level of $1 billion. So it's just like stepping on the grass and saying, look, the grass doesn't grow. This is not the right approach. It's a self-fulfilling prophecy.
Right.
So I had a hypothetical and on the point of I guess you would call it space archaeology or xenoarchaeology. I mean, we have xenobiology, which is a subfield of synthetic biology already. Like there are scientists who are xenobiologists, and I think some of them were involved in just recently when they found that was the sulfide gas or the gas coming off of Venus. Possibly, you had to consult xenobiologists, like could a life form exist? With xenoarchaeology, if you were to be consulted, you personally would be consulted on designing a curriculum for a xenoarchaeologist. Like, what would that look like? Like, I'm curious to think, like, what would it look like?
Well, I have a weekly commentary in Scientific American once a week or 2 weeks. And one of them was on this subject. And right now, the way I see it is we will find more interstellar objects, and some of them would look as weird as Oumuamua was. And what we need is to take photographs, close-up photographs, which we can do. If we get an alert a year in advance, we can send a spacecraft that will intercept the trajectory of those and maybe even land on them, just like OSIRIS-REx landed on asteroid Bennu. And then that's the first step to take. Basically examine all the objects that come to our vicinity that we can identify, say with the Vera Rubin Observatory, that look as weird as Oumuamua was, and plan to take a photograph of them and find those plastic bottles among all the rocks there. Now, some of them would be really rocks. I mean, the second interstellar object that was found by a Russian amateur astronomer named Gennady Borisov, and it looked just like a comet. And so people came to me and said, well, this one looks like a comet. It's the second one discovered, and it's obviously natural. So doesn't it convince you that Oumuamua was also natural? And to that I said, if I find a plastic bottle on the beach and then I see rocks afterwards, it doesn't make the plastic bottle a rock.
Right. Yeah, exactly.
And then so I would kind of ask what, so if we were to say find this plastic bottle, scientists find a plastic bottle, space bottle, how would they go about approaching it? Like, what do you think would be the overarching theory or the working theory that they should go against it? Should they compare it to bottles on Earth? Could you compare it to like analogs of what we have? Whereas perhaps this space culture could be wildly different or have developed completely different from us. Like, how do you think they should approach it?
Oh, it's very simple. In science, this should be part of a scientific research program. In science, you want to get as much evidence as possible, as much information as possible, because that helps you figure out what it's all about. And so in this context, what you want is to land on such an object just like OSIRIS-REx landed on asteroid Bennu, and then explore it. Just, put your hands around it and see what it's all about, and get as much information as possible, and broadcast it to Earth, and maybe even take a sample of what's on it and bring it to Earth. OSIRIS-REx took a sample of the material on Bennu and is supposed to bring it back to Earth. And you can imagine something similar. And then, of course, once we figure out what the technology is all about, it can advance us, because if it took 1 million years to develop that technology, it may represent what we will develop 1 million years from now. So it's sort of like giving us a jump start, a quantum leap in our own development to figure out what it's all about. So I think we should be humble, modest, not try to forecast what it's all about, but just learn what it's all about. It's a learning experience. Just think about a caveman that is presented with a cell phone. The caveman is used to playing with rocks. So the first thing the caveman would say, the cell phone must be a shiny rock. But then once the caveman starts...
One of those flip rocks.
Once he starts playing with it, it will start showing all kinds of features that rocks do not show. So, as long as the caveman is sufficiently intelligent, then, he will try to figure out what it's all about. And we can learn from studying these objects.
Right. Now, I wanted to ask, because I know the answer, but I want a little hypothetical. You say it's very hard to pinpoint the origin of Oumuamua, because Oort clouds extend so far out that they almost touch other Oort clouds of different systems. But do you have any guess of where this thing may have came? Just a guess, hypothetical.
Well, the big problem about Oumuamua, that was another very weird property that it had, was that it was parked in the galactic parking lot. And what I mean by that is the stars are moving relative to each other at some random speed. And you can average over these motions of stars in the vicinity of the sun, and you get to a frame of reference that is called the local standard of rest, which is basically the frame of the galaxy locally when you average over the random motions of the stars nearby. And it looks like Oumuamua came from that frame. It was at rest in the local standard of rest, and only 1 in 500 stars is so much at rest in that frame. So that was very weird, because if it came from a star, it should have inherited the motion of the star relative to that frame.
Right.
So why would it be in the local standard of rest? I mean, I can think of a couple of possibilities. Either that it's a member of a grid of objects that are used for navigation, just like road posts, that if you navigate in interstellar space, there are all these objects that tell you where you are. Another possibility is that it was a part of a relay system for communication. But at any event, the motion of this object relative to the sun was just the motion of the sun relative to the local standard of rest. It was just like a buoy sitting at rest on the surface of the ocean, and the sun, like a giant boat, a giant ship, bumped into it and kicked it. And it's really mysterious as to why it was in that frame. You can't associate it with any star in particular.
That's really cool. The unknown origins of Oumuamua.
Yes.
Since your book has come out, what have the thoughts of your peers changed at all? I know they were very, they're very dismissive at the start, but after reading your book and looking more into your work, has the academic thought of this being an extraterrestrial object changed at all?
Well, those that read the book send me messages that are very positive and congratulatory, but most of the critics probably didn't read the book, and they will not read the book. So the real problem is people operate by prejudice. It takes them out of their comfort zone, and therefore they refuse to go out of their comfort zone, and they dismiss it up front, and they can ridicule the entire idea without looking at the evidence, without explaining the anomalies. And those that try to explain the anomalies as a natural object, they had to come up with something we've never seen before. So that already tells you that what I'm saying, is must be true, because otherwise someone would come with something that we've seen before that explains all the facts, and so I got a lot of feedback from the public, from people like, there was a woman in Malawi that sent me an email saying that she found the book to be great and it convinced her to become perhaps an astronomer. And I was thrilled to get that. And an undergraduate in Colombia, Latin America, that said that reading about my work changed her life. And I get a lot of these messages that basically tell me that whoever reads the book gets very excited. And my hope is that this subject will enter into the mainstream. But at the same time, you see a lot of dismissal, on Twitter and other social media. I don't have an account, and therefore, I don't read all of those. But it is sometimes unfortunate that people attack me personally rather than dealing with the evidence, because it's not about me. It's about this object being weird. And if you don't have an explanation for that, you should accept the possibility that it might be artificial. And it has nothing to do with me. I'm just talking about the evidence, just like I do in the context of any other scientific subject.
Right. Because just like other fields of science, it was like 40 or 50 years of before plate tectonics were accepted, right?
That's right.
When there's a new idea and there's an ingrained thought in the community, it takes so long for people to it almost takes a new generation to come up reading your book and getting involved, right?
Yeah, so that's in the optimistic case, that's what's needed, a few decades. But if you look at the history of humans, starting with Socrates, he basically questioned some popular views at his time and suggested this method of dialogue, and he was accused of corrupting the youth. He was put in jail and executed by being forced to drink poison. Okay, that's Socrates, the great philosophers we ever had. Nowadays, he would have been, that was by the citizens of Athens at the time, and it was a city-state. And nowadays, he would have been cancelled on social media by the Athenians, that culture, because they basically argued that he dismissed the gods that they believed in. And as a result, he needs to die. That was in ancient Greece, and then you look at, for example, Galileo Galilei, when he tried to argue that it doesn't look like we are at the center of the world, that the earth moves around the sun. The philosophers at the time just put him in house arrest so that he will not have a lot of influence. And what did they accomplish? They remained ignorant. They didn't look through his telescope. And the earth continued to move around the sun. The earth doesn't care what these philosophers are saying. Reality is whatever it is. Even if we close the windows and not look out, our neighbors are still out there. If think about being on a street, who cares whether you look out the window or not? Your neighbors exist. They have nothing to do with whether you accept them or not. And so, the same is true about Giordano Bruno. He was an Italian scientist, philosopher that argued that, other stars may be just like the sun and they may have planets like the earth. And as a result, they may have life near them. And he was burnt on the stake. And there are many such examples, even in recent history, of ideas being dismissed. And so there is nothing new here, except that I'm disappointed that we haven't learned a lesson from history, because, what I'm talking about is a matter of common sense. We know that half of the stars, like the sun, have a planet the size of the earth, roughly at the same separation. And so if you arrange for similar circumstances to those on earth, why wouldn't you assume, as a matter of common sense, that you get similar outcomes, that cultures like us, technological civilizations, are common, that we are just like ants on a sidewalk, there are many more, and that there is nothing special about us. That would be the starting point, rather than believing that we are unique and special and we need extraordinary evidence to actually find if there are others out there. And by the way, we shut off the window. We don't even want to look.
Right.
We don't fund it, and we ridicule anyone that discusses the possibility that they might exist. So, I mean, that to me sounds like a point of view from ancient history, from the Middle Ages or something. But how come in the 21st century that is the prevailing view of the scientific community, of people in academia? And I think the public in general is much more open-minded about this question.
In the scientific community, have you kind of noticed any because the government's come out and released the footage of the Nimitz and the Tic Tac of those unidentified flying objects? They're not sure what they are. Has any of that impacted the scientific community of maybe them being more open to these things being artificial, with the government coming out with these, military videos, and you have these accounts of these eyewitness accounts? Have you seen any kind of like opening in the scientific community of that? Or are they still taking a hard stance of like, this is no?
No, I mean, on the contrary, the stance gets even firmer, and all this evidence is being dismissed offhand. Now, the way I think we can make progress is if we deploy scientific instruments. Nowadays we have state-of-the-art cameras and audio sensors that could be deployed in the same locations where the reports came from, and we can just do a scientific experiment and see if there is anything unusual. And that will be open data. It will not be classified. And I think that's the way, once again, to convince everyone if there is something unusual. So rather than argue, I think we should just collect better evidence that is reproducible.
Right.
And the same holds for objects like Oumuamua or for these reports.
Awesome. Now, on that note, just a quick one. Do you think any type of ET being has ever been to Earth in the past or present?
I don't know. I'll tell you what my gut feeling is. I think that we are not sufficiently interesting for them to come and visit us. It's presumptuous for us to assume that they are around or that they came. It reminds me of the friends that my wife had when I first dated her. And those friends used to think that there will be a Prince Charming coming to see them on a white horse and making them a marriage proposal. It never happened, and they had to compromise with whoever around. So I think it's a natural tendency of humans to think, we are sufficiently interesting. They will come over and have a party in our backyard. And it's not at all clear to me that we are that interesting. I think things like us probably exist elsewhere in many places. So I wouldn't be surprised if they never came here.
Right on. I know you're a busy man, and we appreciate your time. So we're going to let you go here. But before you go, where can people find your book and more about your work?
If you put my name in Google, Avi Loeb, Loeb, you can get to my website at Harvard University that features all the publications that I put out, and as well as videos of interviews and other things. And of course, the book is available in any outlet that sells books. And I very much hope that people will enjoy it. I'm currently starting to work on my next book.
Can you give us a sneak peek on what that will be about?
It's still work in progress. But it will not be unrelated.
Awesome. Can't wait for it. All right. If you're looking to hear more about Avi Loeb, you can check him out. He'll be presenting at Contact in the Desert, June 25th to 28th. Stay tuned to contactinthedesert.com for the full schedule. I don't think it's been released yet. But Avi Loeb, thank you very much for coming on the show.
Thanks for having me. It was a pleasure.
All right. Take care.
Have a good one.
Bye.
Take it easy.
Thank you. I enjoyed it.
That's not just the sound of that first sip of Morning Joe. It's the sound of someone shopping for a car on Carvana from the comfort of home.
That's a good blend.
It's time to take it easy, like answering some easy questions to get pre-qualified for a car in minutes.
Talk about starting the morning right.
just like customizing your terms so your car fits your budget. Visit Carvana.com or download the app to experience car shopping the way it should be. Convenient, comfortable. The comfort of your favorite seat is now your comfy car selling command center, thanks to Carvana.
It doesn't get any better than this.
Your favorite seat's the best spot in the house. Make it even better by entering your license plate or VIN and getting a real offer in minutes.
There really is no place like home.
And speaking of home, Carvana will pick up your car from yours after you finalize your offer. Visit Carvana.com or download the app and sell your car from your comfy place.